Units and dimensions. In this topic, we will be discussing the following concepts: system of units, length, mass, time measurements, significant figures, dimensional analysis, so these are the four important concepts about which we will be discussing under the topic units and dimensions. So this is the topic 3 of this, units and dimensions. Now let us proceed with the first concept, systems of units. Systems of units. We have some quantity that is represented by Q is equal to N into U, where Q is the quantity, the physical quantity. Q is the quantity. N is the integer, the number of items, number of times you can say. U is the unit. U is the unit in which the quantity is measured. So this number N, that is a numerical value, is equal to what? Q divided by U. When Q is constant, N is proportional to 1 by U, that is inversely proportional to U when Q is constant. When we have two different physical quantities, this Q represents physical quantities. When we have two different physical quantities, let me say Q1, Q2. So Q1 is equal to N1, U1. Q2 is equal to N2, U2. Now we can have the ratio Q1 by Q2, which is nothing but N1 U1 divided by N2 U2. In fact, this unit should be well defined. The unit should be well defined. It should be neither too small nor too large. It should be optimum. The unit should not change with respect to time or pressure, temperature. And also the unit should be internationally acceptable. So these are all the basic aspects about the units. We should have some international system of unit, and we will talk about what are those systems of units. We have got different systems of unit before implementing international system of units. So what are the different systems of units? Take that. Different systems of units. Different systems of units. Cgs system. Cgs system means centimeter, gram, second. That is, the length measurements are made in centimeter, mass is measured in gram, and time in second. So that's why we call it CGS. And we have FPS also, that is foot pounds second. So the length measurement was made in foot or feet, 2 feet, 3 feet, like that, and pounds, that is weights were measured in pounds. Then time is measured in second. Another unit is called MKS, that is meter, kilogram, second. Now we have SI unit. It is called System International D Units. That is the French name given to International System of Units. Here we go by meter, kilogram, second, and we also include ampere, which is represented by A. When it is represented as a word, it should be in small letter. When it is given in symbol, it should be given as capital letter. Similarly, Kelvin, small letter Kelvin, but represented as a symbol in capital K. Then candela, it is represented as CD, small c, small d. And mole, MOLE, but symbolically it is represented as MOL only, mole. So these are the major units, the fundamental units. Apart from these fundamental units, we have supplementary units. So these are all fundamental units. Now we have supplementary units also. Supplementary units. Radian, which is represented as rad. Is represented as rad. Similarly, steradian. which is represented as SR. Radian is given by theta is equal to L by R, where theta as radian, L that is the length of R, divided by radius of the circle. Whereas steradian is given by a solid angle subtended at the center of a sphere. So it can be represented as delta omega is equal to delta S divided by R squared, where delta S is the small surface area, you can say, divided by the square of the radius of the sphere. So this represents the solid angle. So likewise we have fundamental units and supplementary units. Meter is the unit to measure length, kilogram is the unit to measure mass, second is the unit to measure time, ampere is to measure current, Kelvin to measure temperature, candela the light intensity, mole that counts the number of molecules in chemistry. Okay, next one.